Hi everyone, I hope you are doing good. Uh, Today I have to continue lesson chapter 9, 9.2 actually, section 9.2. Uh, it is based on again hypothesis testing, but in section 9.2 we specifically consider this hypothesis testing which based on critical value. Okay. Now we are going to dig deeper in this hypothesis testing. Okay, confidence interval, which you have done in chapter 8, I think you may remember that. Okay, population standard deviation, which is sigma, is known. These are really important. And we are dealing with standard normal table. Let's say C values. Do you remember that standard normal table? Okay, is the appropriate table to use in this hypothesis testing. Okay. Okay. How do we decide whether or not we need to reject H naught? Okay. Test statistic. There is a variable called test statistic. Do you remember that in chapter 6, 5? We start this guy. We started to deal with this guy, test statistic. Okay. Test statistic is a calculated value. Okay. Calculated value uh, which we use to decide whether our null hypothesis uh, need to be rejected or not. Okay, so for this case we will use C scores. Simply this is test statistic. If you remember, we call Z. Remember that test statistic C, capital Z. So we used C scores to get the values. And again, population standard deviation is known. Okay. Okay, rejection region, non-rejection region, critical values. Okay, all three words are unknown terms for you right now, right? Okay, let's see one by one. Rejection region, which mean set of values for the test statistics. What is the test statistic? Z. That leads to rejection of the null hypothesis, which mean some kind of area. Let's say this one, this is some kind of area we call rejection area. We call this is our rejection area. If my C is inside this area, we call reject my Z, something like that. Okay, so this we can say rejection area. Okay, I'll show you that by using another picture. Okay, this is my area, total area. Let's say this is my rejection area. Okay, this colored one is the rejection area. If I have a value here uh, and a value here, let's say, okay, give me a second, I'll use another color. Okay, my value is, these are the values I'm considering. Okay, in this case my value here inside this rejection area, so this is my rejection area, value is inside this rejection area. Okay, then what is this area? This we call non-rejection area or non-rejection region. Okay, which leads us to do not reject our null hypothesis. Okay, so any value inside this we reject our null hypothesis. What we should do? Reject our H naught. In any value here we do not reject our null hypothesis. Clear? Okay, I'll show you more examples on I think, yeah, in upcoming slides. Okay, last one, critical value or values. What is this critical value? When we calculate a value to the test statistic that separates the rejection and non-rejection region, we call the critical value of the test statistic that separate the rejection and non-rejection regions we call critical value. Okay, critical value is critical value is considered part of the rejection region. Okay, you will see how we calculate this critical value, but only thing you should know, it is some kind of value in of the test statistic which separate the rejection region and non-rejection region, something like this. Okay, value, this value. Okay, okay. I can show you those three: rejection region, non-rejection region, and critical value in my hypothesis test using this normal curve. Okay, okay. Rejection region. This is my rejection region. I have colored this. This is my rejection region, and this is my non-rejection region. Non-rejection region. I'll use REJ. This is my rejection region. Clear? Okay, so what is the critical value? Critical value is the value belongs to test statistic which separates the rejection region and non-rejection region. See this value here. This is the limit. Okay, this is the limit which which separate the rejection region and non-rejection region. Okay, now I think you clear that what is this rejection region, non-rejection region, and what is the critical value. Okay, here we have considered significance level, which mean what? Your alpha. Okay, is 0.05. I told you in default we consider alpha is 0.05. Okay, okay, I'm sorry, I forgot something. If something, if my value within this region, which means within this rejection region, what you should do? Reject your null hypothesis. If any value somewhere here within this non-rejection region, what you should do? Reject your H naught. Okay, this is the method how we use to reject or do not reject my null hypothesis based on its region. Okay, okay. Now I'm going to combine the stuff you have learned last time, two tail, left tail, and right tail test. Do you remember? If it is my alternative hypothesis is not equal, then we call it two tail test. If my alternative hypothesis is less than, we use left tail. If my alternative hypothesis is greater than, we use right tail test. Do you remember? See, this is two tail test. Two tail mean not equal, right? So which includes less than and greater than both within one section. Okay, so that's why we call it two tail. It consists of two pieces, less than piece and greater than piece. So it has two rejection regions. Two rejection regions. It is like a combination of left tail and right tail. Okay, see, this is the one rejection region, this is the other one. Any value within these two regions, we reject H naught. We reject H naught. Whatever in between, we do not reject H naught. Okay, so left tail test, left area is the rejection region. Whatever within this region is is leading us to reject the H naught. Clear? Same as the right tail test. Right hand side is the rejection region. Whatever inside here, we reject our null hypothesis H naught. Okay. Same thing here, they have mentioned with the critical value. Here in two tail test case, these are the critical values. These are the critical values. I think here alpha you can consider if you want 0.05 whatever. Okay, this is something like general case. Okay, you have critical values these two in two-tail test. Remember that two-tail test you will be having two critical values. Two critical values. Okay. Why? Because you have two rejection region. Okay. So based on those two, you can calculate two critical values. Left tail test, this is the critical value because it's just one, because you have only one rejection region. Same as the right tail test, you will be having only one critical value. Okay, because they have these two cases, they have only one rejection region. Okay. Okay. How to obtain this critical value? Actually, this critical value is the okay, I'll show you something like this. Critical value, let's say this one. This is my rejection region. So I told you this is your critical value. This point. That's the uh, point which separate your rejection region and non-rejection region. In this section, we use this test statistic or this critical value to find this critical value. This C, whatever you calculate for this value, we call C calculated value, calculated C value, whatever. Okay, this is the value we use to check these critical values. Okay, the probability is alpha that the test statistic will fall in the rejection region. This is your alpha. Do you remember? These areas always we consider probabilities. Okay, this alpha mean rejection probability of this rejection region. In any case, they haven't mentioned what is alpha. You can simply take it is 0.05. Okay, it is not 1/2, it is 0.05. Okay, rejection region, whatever inside this region goes to reject, which means you have reject the null hypothesis. Okay, how we calculate this guy we will see in a few minutes. Okay. Okay, critical values for the hypothesis test at 5% significant level O, alpha 0.05. 5% mean 0.05. If you multiply 0.05 by 100, 5%. Okay, so you can use both. If you want, you can use 5% or you can use 0.05. That's okay. Okay, so two-tail test, this is the what? This is the critical value, not just values. There are two values. Based on what? Based on this significance level. This significance level. Okay, there are two values. Why? Because this is two-tail test. Clear? Okay, you are considering 0.05, but remember, in two-tail case you have to deal with something like alpha over 2, which means you have to divide your significance level by 2 to get these values. Okay, so here your alpha is 0.05, you have to divide it by 2, which means 0.025. Sorry, 0.025. That's the value you have to consider. This is what? This is actually a region. Okay, from left side to and right side. So that's why they have mentioned this region 0.025. Okay, then you can calculate this limit value or this value here, this value in cross mark, this value and this value. It is negative 1.96 and positive 1.96. Those are the critical values in two-tailed case. Most of the time, I mean almost all, you will be having critical values in two tail cases, like same value but different sign. See here, value is 1.96, positive and negative. Clear? Okay, in left tail or right tail, whatever, you can directly use alpha 0.05 here or here. Okay, you can simply select 0.05, you can simply consider 0.05. So this is the area or rejection region. Then you can simply calculate this value, critical value. That critical value negative 1.645. Okay, so what is this one? This one is C alpha. Do you remember that? Or this one, same thing, Z alpha. If you find Z alpha, you will get 1.645. How we do this, I'll explain you later. Okay, but I think this one you have done. C alpha notation you have done, right? Everything measure from right hand side. Okay, this is how we identify what is the critical value. Critical value, first you have to find the test statistic value, then you have to figure it out what is the critical value. This is something like this is the critical value. Now you have your calculated value, you have your critical value. You have to check, okay, whether my calculated value is less than or greater than this critical value. Based on that, and based on tail, right tail, left tail or two tail, you can take the decision. Okay, that's how we do this kind of testing. Okay, uh, I think same picture here, deciding whether to reject the null hypothesis. Okay, whatever, see, your critical value is this guy, negative 1.645. Your rejection region is this side. Whatever inside this region you reject. So your value is this black dot, it is inside the rejection region, so you have to reject. In this case, you have to reject your H naught. Clear? Because this black dot is inside the rejection region. Okay, okay, I have uh, just drawn this table to get you a clear idea, like comparing them, two tail test, left tail test, right tail test, what is going on here. Okay, so this test, I think you may remember this one, based on HA, based on your alternative hypothesis. Okay, rejection region, both sides, not equal means rejection region goes to both sides. See in the picture here, both sides you will be having two rejection regions. First one is reject H naught if your calculated value, this is your calculated value, C cal, this is how we mention our calculated value, C cal. In general, C cal mean your calculated test statistic value is greater than Z alpha over 2. What is alpha? Given significant level. I told you you have to consider alpha over 2. C alpha is this value. See, these are the C alpha value. One is negative, one is positive. In this case, reject H naught if your calculated value greater than positive C alpha over 2, which means reject if your C cal value within this area. Or again, there are two cases. You have to reject H naught if your C alpha value within this range. That's the huge difference in this two tail and one tail test. This is two tail case. You have to check both sides with alpha over 2. Okay, okay, what about left tail? It is easy. Left mean less than. So if you reject your H naught, if your calculated test statistic is less than your C alpha. Your C alpha. Why this is negative? Negative because less than the C alpha case is always negative values. Right? Left hand side it gives you negative values. Okay. Uh, right hand side, what will happen? Right tail test. Reject test note if your calculated value greater than C alpha, which means within this area you have to reject. Anyway, this is the idea. If any time your calculated test statistic value within that rejection region, then you have to reject. Otherwise, you do not reject. That's the one and only idea behind this. Okay. Okay. uh Obtain critical values for one means C test. You know what is C test? Okay, I think we have done. You can consider alpha 0.05 or 5% significant level. They are same. Two tail, left tail, right tail. Okay, two tail case. First consider two tail case. What you have to do? You have to consider alpha with alpha over 2. Okay, this is my alpha over 2 value, and you have to find what is the rejection or what is the critical value. Okay, based on those values, these are the 1.96 and negative 1.96 are the critical values. When you figure it out one value, just flip the sign and you can get the other value, because this is symmetric. This curve is symmetric. Okay, so according to the left tail test, you can simply consider alpha. This is your C alpha. It should be negative. Why? C alpha you can get from right hand side. Okay, so here this is not C alpha, this is left hand side. This should be negative C alpha. So find the C alpha, change the sign, then you can get this value, negative 1.645. Here right tail test, it is just C alpha. You can simply get the value positive 1.645. See this negative positive case, here it is 1.64, here it is negative 1.64. Just change the sign. Okay, you have done these things in last chapter 6 7. Okay, even chapter 8. Okay. Okay, here I have summarized some very important C alpha values that you have to use most frequently. C, here alpha 0.01, sorry, 0.10. Alpha is 0.10. C alpha. At that time your value is, your Z value is 1.82. These are just positive values. Okay, our most useful guys, C 0.05, alpha equals 0.05. What happened? That value is 1.645. Okay, so likewise you can just go through these values, or you can recalculate whether these values are correct or not. Okay, I think it's a good practice. Okay, let's do an example. We have a hypothesis test that they have given calculated value. Okay, we don't need to do any calculations. You are having a right tail test. Okay, what is right tail test? Right tail. So this is my rejection. Right hand side is the rejection under significant level alpha 0.1. Alpha is 0.1. So see, under 0.1 you should know what is this value from last slide. See, 0.1 value is 1.28. I got this value from last slide's table. Okay, now you have this critical value. You have to check your calculated value with this critical value. That's how we come to a conclusion by comparing. You have C cal value is 1.89. Okay, compare these two values. Your value is 1.89, the critical value is 1.28. So is this value inside the rejection region or in the non-rejection region? This C cal value is somewhere here, right? Let me get another value, another color. Okay, this one. See, your 1.89 is somewhere here inside the rejection region. So what you have to do? We reject the null hypothesis. That's the easiest way, right? Okay, let's see. We have right tail test. Okay, alpha this much. So this is your area, this colored area. Critical value is 1.28. You know how to get this value. How we get that? Okay. I'll try to refresh your knowledge by using this one. Right hand side, we need C score. How we calculate the C score? Everything we have in the C score from left to right. Okay, so if we need to find something in right hand side, we just get the 1 minus that value. So 1 minus 0.1 is 0.9. So you have to go to this table, C table, and find what is the row and column which belongs to 0.9 area. So in here, this picture, you can see we don't have 0.9 exact value. You have to approximate the closest one, 0.8997. Then you can get the row first, then column. So value should be 1.28. Okay, you can now you can compare. Critical value is 1.28. Your test statistic value is 1.89. I think it is greater than critical value. See, which mean reject test node, because this is within the rejection region. Your value somewhere here. Okay, so you have to reject it. Clear? Same thing you have to do like left tail test, two tail test, same thing. Here I have mentioned some kind of two tail test, right tail test with different C alpha values. Okay, let's see how they work. I'm not going to do all the things, just try these things by yourself. I'll do few things. A two tail test with alpha 0.1. This is your alpha value. We need to do two tail test. Okay, this is two tail test, alpha value 0.1. Okay, let me do two tail test with alpha 0.05. I'll do that one. Okay, see 0.05 two tail test. uh okay, let's do this one. Two tail test, alpha 0.05. So you have this rejection region, this much is 0.025, the other side is again 0.025. You remember that you have to get the alpha divided by 2. Okay, so whatever inside these two region, reject. Okay, I think my example, next slide example based on the first one, two tail test. Okay, alpha is 0.1, so you can get alpha over 2, right, which means 0.05, positive negative both. Value is 1.645. So you have to find the 0.05 from the C table and get the row value and column value. It is 1.645 for the positive one, but you will be having these two sides, so you have to get the value with different sign, positive, the other one is negative. Okay, clear? Okay, uh this is Z value, I think left tail test case, C 0.01 left tail. So since this is left tail, you have to get the negative z value. You can figure it out what is the c 0.01 and get the negative of that. Clear? So you can get this. I'm not going to do this one. It is a positive value 0.01. See, in this case you first figure it out positive values based on c 0.01. It is positive 2.33. This value is negative 2.33 because this is negative left side, this is right side. Clear? Since this is symmetric about 0, it is easy, right? Just flip the sign. Okay, there is example. They have given a table with values and they have mentioned average is lower than this one. This is the test we need to perform. They have already given the population standard deviation without any problem. There are 25 values, so n equals 25, sigma equals 20. Okay, they have given those two values and we need to perform the hypothesis test which side this keyword lower than, which means left tail test. Okay, since this is lower than case, it's a left tail test. So first you have to define what is mu. Mu is the population mean of all jacks driving distance. Okay, so your null hypothesis always equal h naught, which mean mu equals this given value 600 and 268 yards. Okay, so next your claim HA alternative hypothesis is left tail test. You need to test less than, so less than goes to alternative hypothesis, mu less than 268 yards. Okay, now you have to find the C score based on your alpha. I think they have given those values, so you don't need that value. Okay, first you have to calculate your mean value. You know population mean equals to the sample means, so mu equals to 268, but you have to calculate sigma according to the sample means. So you have seen this equation, sigma x bar equal to sigma over square root of n. You know what is sigma value, it is 20. You know what is n, is 25, so you can calculate sigma x bar. Okay, then we can calculate our test statistic. Do you remember C-cal? Last time they have given those values, you don't need to do anything, but now we need to calculate this C-cal value. How you calculate it? X bar minus mu x bar divided by sigma x bar. So what is x bar? X bar they have given, see, 268. X bar they have they given x bar? I think nope, no, they haven't given x bar. You have to calculate x bar using your table. Summation of xi divided by n, it gives you x bar. Okay, okay. Then you when you calculate x bar, it goes to 264.4. This is your mu x bar. Mu x bar is 268 divided by sigma x bar. It is 4. It is 4. When you calculate, you can get this value. This is your C-cal value, negative 0.9. Okay. Now, what is this left tail test? I told you if they haven't mentioned alpha, you can get alpha equals to 0.05. 0.05 left tail test. Okay, so according to this alpha, what is the C value? Negative 1.645. Why negative? Left hand side, left tail test. Okay, now where is your calculated value? See this one, negative 0.9. Where is that? It is somewhere, where? It is somewhere here, right? Your C-cal value somewhere here, right? Very close to 0, but negative. Okay, that's okay. Clear? So what we have to do, it is inside the do not rejection region, so we do not reject H naught. So interpretation goes to we do not reject the null hypothesis, always null hypothesis, which means H naught. In other words, you can say at the 5% significant level, this data do not provide sufficient evidence to conclude that Jack's mean driving distance is less than 264, 268. Sorry. Okay. So we will discuss more in chapter 9.4 about this, how we calculate this, how we get the conclusion, something like that. Okay. It doesn't matter which side, two tail, left tail, right tail, you have to perform the same thing. If your C-cal value is inside the rejection region, this is your C-cal. Okay. C-cal, it is inside the rejection region, reject null hypothesis. Okay. The last thing you should know is there are a few general steps. First, you have to state the null and alternative hypothesis. In the first place, you have to mention them. Then decide what is the significant level alpha, your null hypothesis, your alternative hypothesis. Compute the critical value based on your alpha. Then calculate your test statistic value, C-cal. This test statistic means C-cal. Calculate your test statistic value and decide whether it is reject H naught or do not reject H naught. Okay. Finally, interpret your result. Keep that in your mind. We never say accept H naught or HA. We say reject H naught or do not reject H naught. Clear? Okay, I think you may have some kind of idea, or you may have some time a better idea about this materials. Please go through these sections again and again and make sure you are done everything up to date. Okay, so I hope you guys doing well in these days, and hope you see in next chapter, chapter 9.3. Have a great day, guys.